All right, I apologize. I tried to fix the auto-focusing thing. I can't figure it out. So that's a problem for later me. We have 10v squared plus 23v plus 12. There's no GCF that I can take out, so we are going to use the guess and check method. For the guess and check method, we need to break apart 10v squared. There are two options there. I could do 5v times 2v, or I could have 10v times 1v. And now I'm not positive which of these it's going to be just yet, so I am going to guess and check my answer. This is a great time to use pencil. I need two numbers that multiply to 12. Well, my options there are 1 times 12, 2 times 6, or 3 times 4. I know that I want positive 12, so they have to both be positive or both be negative. And I want them to add to positive 23, which means they're both going to be positives. So I can put that in right away because I know this will be true. And now I guess and check until I get to the right answer. If I use these factors, the only pieces I have to check are the inside and outside multiplication to add up to 23v. So let's try 1 and 12. 1 times 2v is 2v. 5v times 12 is 60v. Those do not make 23v. That is not my answer. But before you give up, always try flip-flopping them. 12 and 1. 12 times 2v is 24v. 5v times 1 is 5v. That still does not make my 23v. So let's try 2 and 6. 2, 6. 2 times 2v is 4v. 5v times 6 is 30v. That does not make my 23. But let's try flipping them. 6 and 2. 6 times 2v is 12v. 5v times 2 is 10v. Close, but not 23v. So let's try 3 and 4. 3, 4. 3 times 2v is 6v. 5v times 4 is 20v. That's 26v. Not quite right. Try switching them. 4 and 3. 4 times 2v is 8v. 5v times 3 is 15v. 15 and 8 actually does make 23, so I found my answer. If that hadn't been my answer, I would have tried 10v and 1v, but I now know my answer is 5v plus 4 times 2v plus 3. There we go. 9z squared minus 24z plus 16. All right, I do not have a GCF, so I need to guess and check again. The only ways to break apart 9z squared are 9z times 1z, or 3z and 3z. I'm going to look at numbers that multiply to 16. My options are 1 times 16, 2 times 8, or 4 times 4. I know they need to multiply to a positive number, so they need to either both be positive or both negative. And they need to add to a negative number, so I know they'll both be negatives, for sure. Now I guess and check, and I decide where I want to go. I'm trying to add up to negative 24z. I personally would start with 3z and 3z because I feel like it's more likely, but that's just my brain saying that. That's not logic. So I'm going to check that one first. I don't feel like 1 and 16 is going to work, but let's try it. 1 and 16. 1 times 3z is negative 3z. 3z times negative 16 is negative 48z. That's definitely not negative 24z. I don't need to flip-flop this time because they're both 3z's, so it won't change anything. You only need to flip-flop if they were different. So let's try 2 and 8. Negative 2 times 3z is negative 6z. 3z times negative 8 is negative 24z. That makes negative 30z, not the negative 24 that I want. How about 4 and 4? Negative 4 times 3z is negative 4z. 3z times negative 4, Negative 4 times 3z is negative 12z. 3z times negative 4 is negative 12z. Negative 12z and negative 12z makes negative 24z. So here's my answer. 3z minus 4 times 3z minus 4. You can rewrite that as 3z minus 4 all squared it's the same thing. Either one is okay. But we didn't even need to check this one. All right, 25y squared minus 64. This is a special pattern called a difference of squares. This pattern's nice. Essentially, I can think of this as 25y squared plus 0y minus 64. Well, ways to break apart 25y squared, I could use 25 and 1 or 5 and 5, right? 5y and 5y. Or I could go 25y and 1y. But the nice thing about this pattern, to get 64, I could use 1 and 64, 2 and 32, 4 and 16, on and on, right? But I know this pattern is going to be 8 and 8. Because to add to 0, I need plus and minus. When I check this, I have positive 40y minus 40y. My answer is 5y plus 8 times 5y minus 8. The difference of squares pattern. The first thing is a perfect square. The second thing is a perfect square. There's subtraction in the middle. We just take the square root of each of them. One's a plus, one's a minus. All right, x cubed plus 10x squared minus 24x. First step is factor out the GCF, which is an x. When I take out x, I'm left with x squared plus 10x minus 24. Now I'm going to factor that. Leave that x out front, don't forget it. 2 sets of parentheses, and x is first for each of them. 2 numbers that multiply to negative 24 and add to 10. Well, those are positive 12 and negative 2. And there we are. 2x squared plus 8x plus 6. My GCF here is 2, leaving me x squared plus 4x plus 3. Keep that 2 out front, 2 sets of parentheses. I know it's an x and an x to get that x squared. 2 numbers that multiply to 3 and add to 4 are positive 3 and positive 1. There we are. There's our answer. 2x squared minus x plus 6. Well, there's no GCF, so I have to dive right in. The only way to break apart 2x squared is 2x and x. So now I have to guess and check to get that plus 6 and a minus x in the middle. Well, to multiply to a positive and add to a negative, these both have to be minuses. To get 6, I can use 1 and 6 or 2 and 3. Let's try 1 and 6. I get minus 1x, minus 12x. That doesn't work. Flip-flop them. 6 and 1 minus 6x minus 2x. Still doesn't work. Try 2 and 3. 2, 3. Minus 2x minus 6x. Nope. And how about, oh wait, that was supposed to be, yeah, 2, never mind. 3 and 2, I get minus 3x minus 4x. Still doesn't make that minus x in the middle. This one cannot be factored. And I show you that because not every trinomial can be factored. We're going to deal with a bunch that can't be factored later on in this section. All right, x squared to the 4th power minus 16. That is your difference of squares again. What squared makes x to the 4th? X squared. What squared makes 16? 4. So we take x squared plus 4 times x squared minus 4. But wait, there's more. X squared minus 4 is a difference of squares again. I can't do anything with x squared plus 4. That's just got to hang out. But x squared minus 4 is x plus 2 times x minus 2. It's a difference of squares. There we have it. X squared plus 15x minus 54. All right, we'll dive straight in. I got my x and my x. I need 2 numbers that multiply to negative 54 and add to positive 15. All right, factors of 54. If all else fails, start listing them out. 1 times 54 won't make a 15. 2 times 27, can't get a 15. 3 times 18 Ooh, I can get a 15 out of that, because to multiply to negative 54, I know one's positive and one's negative. So if I make it positive 18 minus 3, I've got it. All right, 3x squared minus 11x minus 20. All right, no GCF, so I dive straight in. The only way to break apart 3x squared is 3x and x. To multiply to 20, I could use 1 times 20, 2 times 10, or 4 times 5. Those are going to be my guesses as I try to get a minus 11 in the middle. Notice that one's going to be positive, one's going to be negative because of this minus. So I'm going to rule out 1 and 20 right away because I just don't think that's right. Let's try 2 and 10. If I do 2 and 10, I get 2x, I get 30x, no way to make that 11. If I flip-flop them, 10 and 2, I have a 10x and a 6x, also not going to make it 11. All right, let's try 4 and 5. 4x and 15x, well, hey, if I take negative 15x and positive 4x, it's going to work. So I will put the plus 4 because I want that to be positive 4x. I'll put a minus 5 because I wanted that to be negative 15x. All right, so the next method is factoring by grouping. Think about a GCF, and this is only going to work with polynomials with 4 terms. So what I do, I group together 2 terms, and I take the GCF out of that. So 2ax minus 6ay, the GCF is 2a. What I'm left with is x minus 3y. And then I do the same thing for the other 2 terms. Minus 5x plus 15y. I'm going to take out that negative 5. If that first term has a negative, you'll always want to take that out. I'm left with x minus 3y. Now notice that those pieces are the same. We're essentially taking out the GCF again. That piece is going to come out front. When I take that out, these 2 pieces just fill in the second set of parentheses, 2a minus 5. And there we have it. You could technically do it in either order. You could have 2a minus 5 times x minus 3y. So let's try this other one. 7cd minus c squared. Take out the GCF of that. It is c. I'm left with 7d minus c. 14d minus 2c. Take out my GCF. It is a positive 2. I'm left with 7d minus c. Now, if these factors did not match, my 7d minus c, then I would not be able to use factoring by grouping. But since they match, there we go. And we take these remaining pieces and make them the second factor, c plus 2. And we are factored. 3uw plus 12uz minus 2vw minus 8vz. Same thing, start off with these first 2 factors, or terms. Take out my GCF. My GCF is 3u. I'm left with w plus 4z. Then I have minus 2vw minus 8vz. Well, I'm going to take out a negative 2v because they both have that. That leaves me with a positive w plus 4z because I took out the negative with it. And now we take that common term matches, so it is our first one. The second term will be these 2 pieces, 3u minus 2v. And we are factored. All right, we'll pause this video for here.